Hello and welcome to the lecture about user interface and multimedia APIs inside web browsers. The main objective of this lecture is to give you a generic overview of the capabilities of current web browsers. However, we will get a bit technical sometimes, so we are going to cover some low-level technical details of several APIs as well. HTML5 specification does not state only the specification of the HTML language itself, so it's not just a list of HTML tags, but it also defines a number of JavaScript APIs which a browser should support, namely APIs oriented for user interaction, so inputs, mouse control and stuff like this. Also some multimedia manipulations, so drawing images or vector images and operating with video, audio or even recording from the camera. Also, sometimes we need to support various different devices like portable devices, so there are some limited ways how to detect that we are on the portable device and detect various things like orientation of the screen. And also we need to do many other things. For instance, we need to process data downloaded typically from Ajax. We need to process sometimes data even at the client side before this data is sent over to the server. And sometimes we need more complex ways of communication. Besides the traditional Ajax API, we can also use bidirectional communications like WebSockets or even peer-to-peer communication between two users using WebRTC. Unfortunately, not all of these APIs are always fully supported in all browsers, and sometimes these APIs are somewhat technical or developing over the time. So it's a good thing to know where to find these APIs. Good place to start might be this page. It's called HTML5 test. Actually, it's not just an overview of all the technologies, but it's mainly designed as a testing suite, which checks whether individual technologies, individual APIs are available in my browser. However, for each technology, for each API, I can see the current status of this API. There are some links for the documentations, and also I can see how this particular API is supported amongst all the browsers. We will start with mouse APIs because mouse is perhaps the most often used control for the user. You already know the most basic events related to mouse, like on-click handler or on mouse down handler, or perhaps on mouse move event. Now we will do something slightly more elaborate. We will start with drag and drop API. Just to clarify, I believe everybody knows what drag and drop is, so just a quick review. Drag and drop is a gesture when you grab something using your mouse. By grab I mean you typically click a button down on some element, on some item, and then you move the mouse to some other location, and then you release the button expecting that the object will follow the mouse cursor and will be released in the target area. This is often used for moving or copying items, typically things like files or elements in some editor like selected text. Within the browser you can use it for whatever you need, and you can also use it to move things inside the browser and outside the browser. Outside the browser you are typically moving things like text, sometimes images. Inside the browser you can drop things like files. Important thing to know is that there is a better support added with HTML5, so there's also some older API for drag and drop which was defined prior to HTML5, but if you encounter it, don't use it, use this new API. So first of all, there are some specific HTML attributes. The most important one is the draggable attribute. You can add it to all HTML elements which should be draggable, so all these elements should be movable by mouse drag and drop gesture. There is also this drop zone attribute, which should designate drop zone areas, meaning the elements where some dragged item can be dropped. However, to my best knowledge, this attribute is not widely supported amongst the browsers, so I don't recommend using the drop zone yet. Drag and drop gesture fires many events. I will make a quick overview of them because they are quite important and it's slightly difficult to recognize them. So first one, drag start is fired on the dragged element when the operation itself begins. The important thing is that this event should probably fill the data transfer property. Sometimes the data transfer is filled automatically by the thing that you actually grab by the mouse. However, if you need to place something specific, this is the property of the event, of course, which needs to be filled, so we correctly specify what is actually being dragged. During the dragging, these three events may fire on possible targets, on possible destinations. This one is particularly important because it determines whether the possible destination is recognized as a destination or not. By default, the drag over rejects all the destination. So if you want to accept a destination as a possible destination, accept an element as a possible destination, you will need to prevent default the event. So you will prevent the default handler of this event. And of course, finally, when the operation is over, when you drop the element, the drag end will be fired on the dragged element itself. So this is perhaps the best place where you should handle the actual operation, which will be triggered after the whole gesture is finished. Another place where you can handle the termination of the whole drag and drop gesture is the drop event, but this one is fired on the destination element where the dragged element is actually being dropped. In my personal opinion, the drag end event is slightly more convenient in most cases. However, this might be also acceptable. The transfer data property will be also present in all the drag and drop events I've mentioned. So typically in the drop event, or in the case of drag end event, this is where you should look for the data that are being dropped in some place. You can set and read drop effect, which can be copy, move, or link, to determine different types of operations, for instance based on whether additional buttons were pressed. So for instance, if you just drag and drop something, it means move. If you drag and drop with Control or with Shift, it may mean something different, like copy. And also there are some things that help you access the data of the drag and drop data transfer. Also, automatically some items are filled. For instance, if you drag and drop file, this is perhaps the most important property. If you are dragging files, this is the list of files which are being dragged. So for instance, if you drag and drop files into the browser, you will get relevant handlers of these files in here. In many mouse gestures, it is very important to track actually the movement of the mouse. In this case, you can track the mouse movement using the mouse move events. However, the bad thing is that these events are only captured as long as the mouse cursor is hovering over the element who captures them. Sometimes this is very limiting because sometimes you need to capture all the mouse move events even when the mouse cursor leaves the area of the element and then returns. Fortunately for this, there is this capturing function. You can turn it on using this method. This method is typically invoked at the beginning of some gesture. So for instance, when the mouse button goes down, you can invoke this capturing to receive all the mouse move events, even if the mouse cursor leaves the area designated for the element. To terminate this capture, you need to call document release. Note that you need to call this on the document because the target element may not be still relevant. So this method actually releases any captures in the whole document. Another way how you can deal with a similar situation is to lock the mouse pointer inside an element. Actually, locking mouse inside element it has a slightly different behavior than the name could suggest. It ensures that the pointer does not leave the element, but it also ensures that it is not clamped, so you can move the mouse cursor indefinitely. And the cursor itself is hidden, so it no longer corresponds to some actual coordinates, but the coordinates of the mouse are infinite. And this state is persistent, meaning the mouse pointer will remain locked until you explicitly release this state. So how to initiate it? You just request a pointer lock for some specific element, and later when you decided that's enough, you can exit pointer lock. Again, this one is invoked on an element, this one is invoked on the document. I have not found many useful applications of this particular API. However, if you're doing something like, let's say, moving a camera in 3D using your mouse, then this might be a good idea to locking the pointer might be a good API to use. So this covers the mouse APIs, and now we move our attention towards text APIs. The first one I would like to present is the text selection API. It gives us a way how to read and manipulate the selection of the text, meaning the part of the text which is being highlighted, and then it can be, for instance, copy-pasted. To access the selection, we can use this method. It will return us a selection object which represents the API itself. What we need to know is that a selection may not be continuous, so it's divided into ranges, and one range represents one continuous block of the selection. We can use these properties and methods to access them, and of course we can manipulate the ranges, so we can add another range, for instance. Each range is again an object which represents one continuous selection of a text. The start container and end containers refer to DOM nodes where the actual selection starts and ends, and the offsets, their respective offsets, are the indices inside the text, so they are basically offsets inside the characters of the text. To quickly access the beginning and the end of the whole selection, we can use these properties of the selection object. However, these don't cover the cases when the selection is not continuous. So if the selection is only continuous, or you don't care about the gaps, you can quickly access these read-only properties to find out which part of the document is actually selected. Second API, which goes hand to hand with the first one, is Clipboard API. You can access it via Navigator Clipboard property, which will give you an object that has 4 basic methods for reading and writing the current contents of the system clipboard. Yeah, if you just felt this tingling, chilling sensation running down your spine, then you probably have a keen sense for web security, because this is potentially very dangerous API. So it doesn't go just without safeguards. It has some warrants. For instance, all these APIs return actually promise, so they don't return or write the contents immediately, but they return a promise, and that promise resolves after the user explicitly approves the operation. So don't worry, your browser cannot immediately access the global clipboard of the whole system, but the browser must give the user an inquiry, and the user must explicitly allow this operation to succeed. Furthermore, if some clipboard operations like copies or pastings take place in your web page, a clipboard event is triggered, so you can handle this particular event and act upon it. Typically, you can intercept it and modify the clipboard content. So if you're, for instance, copying or pasting something in or out of the clipboard, you can modify the contents. And finally, if you want to trigger some of these operations manually, remember there is this document exec command I've already told you about, and this can be used to trigger any of these 3 copy, paste and cut operations which actually work with the global clipboard. To give you a quick overview how this works, let's just say I would like to read some text from the clipboard, but I've just recently copy-pasted my most secret password, so it wouldn't be, let's say, safe if the navigator can just directly access the clipboard. So if I execute this code, the first thing that happens actually is that the browser asks me for permission, and I have to allow this permission. And as you see, if I allow this permission, if I explicitly allow the browser to access the clipboard, then this promise will resolve. So this function will be called, and this function basically gets the contents of the clipboard and logs it to the screen on the right. So this is my top secret password. Let's move on to the APIs for portable devices. First of all, I would like to point out that whilst most of these APIs I'm presenting in this lecture are currently working at least in the most recent browsers, this set of the portable APIs are, let's say, sporadically supported. So not all of them are supported in all the browsers. So be careful when selecting which of these APIs you will trust. First of all, there is this API regarding the screen orientation. So this will get us whether the screen is oriented as a landscape or portrait. Sometimes you can get more detailed information. For instance, some devices may choose to give you also a rotation angle in degrees, so you might have slightly more detailed information. Also, there is this orientation on change event, which is triggered whenever the orientation changes. And finally, some devices may allow you to lock the orientation, so when the user actually rotates the device, the screen won't change its orientation. Remember, not all of these features has to be supported in all of the browsers. Furthermore, remember that there is also a media query in cascading style sheet regarding the screen rotation. So if you just need to get the right rotation for the proper layout of your page, you can do it solely with cascading style sheets. You don't need JavaScript APIs for that. Second API is more detailed API for device orientation. It's member of the window, and it will give you really the vector, meaning 3 coordinates as a event parameters, which will actually which will be modified every time the device is slightly rotated. So these are the data from the accelerometer, if your device has the accelerometer, of course. Another API can give you some information regarding the ambient light of the device. This might be particularly interesting for the portable devices, since they are more likely to be taken outside, where the direct sunshine can inflict the way how you can read, the ability to read these devices, and also you can use them in dark places. Final and fourth API is the vibration API. It can be used for, let's say, soft notifications. This is actually quite interesting because it comprises only one method, this vibrate method, and the method itself gets length, whilst the length may be a simple number which indicates the duration of the vibration in milliseconds, but also you can give here an array of lengths, and the values in this arrays are alternating durations of vibrations and pauses. So if you want to vibrate some pattern, like for instance SOS or something like that, then you can do it. You can provide an array of numbers, and this array will represent the pattern which will be actually vibrated. I have prepared some examples. Unfortunately, I'm not sure how to easily incorporate them in this video. So if you happen to have some tablet or cell phone with a modern enough web browser, then you can download these examples and try them on your own. Another topic which is slightly related to portable devices but actually has impact on all other devices as well is geolocation. Actually, it has some particular interest to some parties today because of this quarantine things, smart quarantine things regarding the pending pandemic. So it's maybe even more important nowadays than it was. So first of all, there are two ways how to track the user. You can track it using the client side, using the client API, and using the server side. At the client side, actually the specification, the JavaScript API defines only the methods themselves, but the API does not specify how the browser is supposed to get the location information itself. So the browser resorts to many resources how to detect the location of the user. First of all, there are these things like Wi-Fi networks. So most mobile devices, portable devices and laptops have Wi-Fi access. So in this case, Wi-Fi can be used to detect other Wi-Fis, and there are maps, there are lists of publicly known Wi-Fi networks and their locations. They are typically tracked by monitoring vehicles like Google Street View vehicles or Cessna Street vehicles. So these maps can be used to triangulate your position. Similar things goes with GSM cells, with BTS, actually with iNode stations. So if you have a cell phone connectivity, if you have a GSM modem in your device, then this modem can give you a list of nearest terrestrial stations. And again, there is a huge list of locations of all terrestrial stations, so you can use this for triangulation of the position. And of course, if you're running your code on something like a cell phone or tablet, it might have a GPS locator itself, so it can give you a very precise information regarding the user's location. If you're on a device which does not possess any of these, so it does not have any wireless connectivity whatsoever, and it does not have a GPS signal, you can still resort to public IP geolocation. So you can translate public IP addresses into geolocations. However, this information is typically very coarse, so this is very rough information. Often it will give you an approximation of a city or area of a country where the user might be, but it won't give you any precise information. Furthermore, you have to know that if the user is behind some sort of anonymization proxy, for instance, he or she might get a completely different public IP address in a different country. So you might sit as well in Czech Republic, in Prague, and via this proxy, your public IP will appear to be in a completely different country, far, far away. So it's not 100% correct. There is also a moral aspect of geolocation. Whilst the client-side geolocation is completely in the hands of the user, and the user must explicitly allow this feature, the server-side geolocation, which can be used, which can rely on IP address only, of course, is not under the browser control, so it's not under the user control, and you may use it always. The question is whether you should use this technique or whether you can use this technique. To use this for, let's say, additional security may be okay. I'll give you an example. If I go to a different country and I try to log to my Gmail account, if I try to log in there, the Google will detect that I'm logging from a location I've never logged before and explicitly asks me to verify my password again, or to use two-phase authentication to verify that it's really me. It's not just somebody in a different country who just hacked my account or get my password. So this might be a good security feature, actually. Use knowledge of location of the user, like the city where the user resides, might be still okay okay-ish for, let's say, focusing advertising or focusing services to that user. And another example, if I write open pub inside the browser, I would expect that it will give me pubs relatively near me, so it will give me a list of pubs in Prague, but not list of pubs in Brno. And finally, crossing these lines without the user knowledge might be tricky, so it's not a good idea to track the user's movement without explicit knowledge of the user, or to misuse the data passed from the more precise things like GPS and save them without explicit user knowledge. Remember, this is a very sensitive information, and there are rules like GDPR which prevents us from, let's say, doing excessive manipulation with this data. The geolocation interface is hidden in the navigator geolocation attribute. I will actually take this opportunity to present a good way how to test for this for presence of this API. Maybe I should have presented this earlier, because this actually goes for all the APIs. Remember, when we want to test whether some API is present, we always test for the functionality. Never try to test for the version of the browser or type of the browser, because that's just not right. That's very complicated and not 100% sure. So the best way how to do this is something like this. We will check whether the geolocation object is present in the navigator object, and if it does, then everything is okay. If not, you should fall back to some code that does not require geolocation. The API itself actually provides two basis functions. First one, perhaps the most important one, is one-shot request, so it will give you the immediate position of the user, and the second possibility is to get a repetitive updates, which will give you frequent notifications that can be used to monitor users' movement. The one-shot request API is somewhat old-fashioned because it was designed before promises, so it is still asynchronous because it may take some time to calculate the position, but it won't return a promise. Actually, it gets two callback methods. Obviously, success is invoked when the position is retrieved, and error is invoked if the retrieval fails. The third argument is options. Options is an object which can hold specific flags and switches that manipulate how the position will be retrieved. This first switch will actually tell the browser whether it should take a special care when calculating the position. For instance, if we are on the cell phone might have a GPS locator. However, the GPS locator is not always on because it consumes a lot of energy. So when we turn this switch on, it will indicate that we really need a precise position. So the browser might ask for the GPS location to turn on the GPS locator and get a precise position. If this flag is not on, the browser may resort to computing the less accurate position, let's say from GSM signal instead of GPS signal. There is also timeout, how long we are willing to wait for computing the position, because especially when calculating triangulation or retrieving the data for GPS might take some time. So this is the timeout which will be imposed on the request. And maximum age can be used in case the data can be retrieved from cache if there are some cache location data. So this is like a restriction how old the data from the cache may be. The success callback will return an object with following properties. Besides the timestamp, of course, the most important are the coordinates. The coordinates are returned as two doubles, latitude and longitude, in VGS coordinate system. So you will basically get the world position in these two numbers. Also, it will give you accuracy in meters, so how sure the system is about your position. This is also very important because it's a very big difference if you get your position from the IP address or something very imprecise like the Wi-Fi's, because the accuracy may be in hundreds or even thousands of meters. You can be sure that you are within a city perhaps, but if you utilize the GPS, the accuracy can be within the range of meters, so it can give you a very precise location. Also in this place I would have given a demonstration. Unfortunately, on my laptop, which uses Wi-Fi to give me the geolocation, actually the position is quite precise, and I'm not quite ready to reveal my home location, since I'm recording this from home, to public video. So again, I implore you to try this example at home on your own. And I will just move on to the final part of the geolocation API, which represents the repetitive updates. The API is similar, so we have this watch position function, which again gets 2 callbacks and the options as an object, but it will start a repetitive watch of the location, so the success will be called repetitively, and this function will yield watch ID, so it's somewhat similar to timer ID, to timeout ID. It can be later used to clear the watch, and the ID will be passed to the clearing function, so this will actually stop the repetitive updates. The last API I would like to present in the first part of this lecture is Web Notifications API. This API allows the browser to notify the user about very important events, such as new email, pending calendar event, or some progress report, which might be very important for the user, but the browser may not be visible at the moment, or the current tab that want to make this kind of notification is not currently on the top. So for these notifications, the browser will actually make this message appear at a system level. So it's like a system-wide notification, and for these reasons there are some limitations. First limitation is that the notification itself must be permitted explicitly by the user. So the user must permit a particular web page to send these types of notifications. It's very similar to the API you've already seen in the clipboard. So you can ask for permission. If the permission is granted, you can read it. If the permission is granted, you can read it here, and you already know that the web page is allowed to make these kind of notifications. If not, you can request it, and this request returns a promise which will be resolved after the user explicitly permits or denies this type of permission. So if the user permits this promise will be resolved as a successful promise, and you will know that you are granted permissions to display notifications. If you are granted the permission to create notifications, you simply create a notification by creating its representative object. Notification is given a title, which is the most important information, and optionally it may be given some options like more detailed text of the notification and many other things, including icon, sound that will be played on the notification, or even vibrating pattern which will be employed if you are on a handheld device that actually has the vibration built in. The notification object itself has some events that can be handled. So these are these events. You can attach handlers to these to, for instance, detect when the user explicitly closes this notification, so whether the user is notified or not. Or after a time, for instance, you may explicitly close this notification by your own by invoking this method on the notification object. Fortunately, I can give you this demonstration without compromising my security. So this is my demo web page. I have been already granted the permission to show notification, so I can click notify button, which creates the notification itself. And you may note in the bottom right corner that there is a new notification that appeared. It also includes some icon, and I can explicitly close this notification. Now we move to the second part of this lecture, where we cover multimedia. We start with the simplest ones, with images. Remember, images on web page are quite powerful, especially in combination with cascading style sheets. You probably know a lot of things about images already, so I just jump straight to the point. First of all, how we can create and load new images. It's actually very simple. If we want to create a new image which wasn't loaded on the page, we can do it thusly. And if we provide a URL like here, this URL will be immediately targeted. It will be immediately downloaded on the background via HTTP protocol. So this is basically another way how to trigger background HTTP request. Whether a particular image is already loaded can be checked using this property. Also, a good idea is to check the original proportions of the image, because the image is normally resized to the width and height of the element. So if you want to know the original width and original height of the image itself, these are the properties you should pay attention to. And finally, you can wait for the image to be loaded, so you can wait for the onload event, which is fired once the image is completely loaded. Let me give you a quick example of what can be done using very simple techniques, just the images and CSS. So this is a normal image, and I can create a kind of a zooming window which actually uses a different image. I have two images. One is smaller, this is the whole image, and the other, which is in a much finer resolution, is downloaded on the background. And in this div, which uses a round border, so it looks like a circle instead of a rectangle. So in this div, which is moving alongside with the mouse cursor, there is this large image displayed on the background with appropriate dislocation, so it will create an appearance that I am actually zooming the original image. This is another way how to load an image on the background and then display it as a normal DOM element. So in this case, we are fetching an image using normal GET request on the background using the fetch API. The image is a binary blob, so we have to unpack it in a slightly different way. We have to unpack it as an array buffer, and subsequently we peg this array buffer into a blob. The details are not that important right now. I will explain them next week. So we have this blob, which is a binary object that represents an image, and what we can do over here is we can create an object URL. So we can take a blob and make the browser register this blob and assign it a local URL, temporary URL, which is valid only within this page, and this URL can be used to fill the image source, to fill the URL of the image. So no other image will be downloaded for this particular DOM object, but it will be assigned an associated blob object from the cache. Finally, there is one other useful information regarding images. Actually, I've already mentioned this in the basic course, so this is kind of a revision. We can provide images directly inside URLs themselves. So we can, instead of normal regular URLs, we can use this data URLs. Data URL is still a valid URL. It has a slightly different schema. It does not use HTTP or something like this, a protocol as a schema. It uses data as a schema. It is followed by the MIME specification of the contents, the encoding, and then if we use base64 encoding, which is typical for this kind of data URLs, then we have the data encoded in base64 encoding. Base64 uses only safe characters, so all the characters are represented as text. So this is a very useful way if we want to pass somewhere an image where we can only pass down a string. So if you need to encode an image in a string, this is a very useful way. However, it's slightly inefficient because since base64 encodes every 6 bits in one character in 8 bits, so there is some increase in size, it takes more space. On the other hand, this goes for all the other content, so this is not just specific for images, but we can use it for any other content, including HTML documents themselves actually. So it might be intriguing to combine some sort of data URLization alongside with URL shortening services. Basically, technically, you can save your entire data page into URLs and then use this URL shortening service to store this its contents indefinitely, but it's just a theory. If you need to manipulate base64 directly inside the browser, there are some functions that might be useful. This is encoding and decoding function for base64 encoding. Besides traditional raster images, we have also support for vector graphics. Actually, HTML5 allows direct embedding of SVG. SVG is a format based on XML, so it's kind of compatible with HTML. So all we need to do in HTML document is to create SVG element, and inside this SVG element we can place the entire SVG document, i.e. the image itself. Fortunately, since we are still in the realms of HTML, XML, we can manipulate all the elements inside SVG using all JavaScript API. So for instance, we can access the nodes inside the SVG document and we can modify them. We can also use cascading style sheets to manipulate these elements, so we can combine SVG components and cascading style sheets to create animations. This is an example of a simple SVG image embedded directly in HTML document, and I'm using JavaScript to modify it slightly based on several events. For instance, if I move mouse cursor to left or right just beside the head is rotated using cascading style sheets to the left and right. I can also place mouse cursor over the eyes and use CSS to shrink the eyes, and also by clicking on the legs I can trigger CSS animation that alternates the position of the legs using absolute positioning. So basically, by these simple combinations of SVG and CSS, I can create rather cool animations. Although CSS is a quite powerful tool for creating animations, sometimes we need to do them manually. Typical example would be when we need to coordinate an animation of multiple objects and synchronize them. In JavaScript, it's quite easy. We can request animation frame, which is a request for a callback which is invoked immediately before the screen is re-rendered. So it's recommended that all the animation updates goes to this callback. This function returns an ID, and if we want to cancel the request, we can use a cancellation routine with the ID previously yielded from the request animation frame function. This function requests the callback to be called just once, so this callback needs to be re-registered repetitively if we want to do a repetitive animation. So it's a normal practice that the callback itself calls another request animation frame inside to ensure looping effect. Also, this callback is given precise time in milliseconds, so it can compute how much the scene changes from the last animation frame. That's a kind of normal practice in animation. So if you have ever implemented a game, for instance, the frame loop typically computes how much time passed since the last frame to compute how much all the elements of the scene moved from the last frame to the next frame. And through the animations we get to the video. HTML5 provided video elements, so including a video inside web page is today very simple. All you need actually is to provide this video element, and inside this video element you can specify one or more sources. The source is basically just a link to the video. As you can see in this example, there are multiple sources, but all these sources point to the same video, just in different formats. This is perhaps the biggest flaw of this video element. It does not enforce the browser to support particular video technologies, particular video codecs. So it's up to the browser which formats, which codecs the browser supports. So it's a normal practice that the designer of the web page provide the video in multiple formats to ensure that at least one of these formats is recognized by the browser and can be played in the browser. Also, there is this attribute controls, which you can see in the video element. It indicates whether the controls of the video, like play or pause, are visible, so the user may directly affect what's being played on the screen, or you can hide these controls and control the video element from the JavaScript itself in case you don't want to have the user direct control over the video. This is a brief overview of most of the methods, properties and events of the video element. I'm not going into the details here. Most of these properties and methods are self-explanatory, so they are pretty straightforward. I just want to show you that the API for controlling the video is quite thorough, so you can do almost anything normal with the video element. The last and the ultimate element for creating computer graphics is called Canvas. Canvas is very simple, very straightforward. It just provides a viewport for drawing. So basically inside HTML you just create this Canvas element with appropriate viewport size, and then later you can refer to it and use it for drawing. Drawing is performed through something which is called context. The canvas can retrieve its current drawing context, and there might be various types of contexts. All the canvas implementations are obliged to implement 2D context, which is like the most fundamental, the lowest level of context. So it gives you operations like draw a pixel or draw a line. So it's very low level. However, the browser might implement other types of context, for instance, context for 3D graphics. Of course, Canvas is a static element, so it displays static drawing. However, you can use timers, or better yet, you can use the animation frame events I've just told you about to create animations inside Canvas. There is one thing which is not perfectly straightforward, so I'm pointing it out now. Remember, the canvas is cleared when it's resized, so be careful to set the appropriate size at the beginning. So if you resize the canvas, it's cleared altogether. On the other hand, resizing canvas to the same size it was before is one way how to clear the canvas, so it's kind of a hack which is being used all the time. This is a quick overview of the capabilities of the basic 2D context. Beside the fundamental operations I've told you about, like creating lines or rendering texts, it's also capable of performing basic linear transformation and also deal with the raster graphics data. So you can get or set the raster data themselves. It might be useful if you want to snapshot the whole canvas to an image, and also you may project images or even videos on canvas using this API. Since the basic drawing context is somewhat crude, there are many libraries that focus on various aspects of computer graphics. This is just let's say top of the list. Also, if you want to do something specialized like creating graphs or diagrams, there are other types of libraries. So these are basically the fundamental libraries, these are specialized libraries. Some of these libraries also provide fallbacks, so in case you don't want to draw them on canvas, they can also export SVGs. So actually, in case you want to create some computer graphics, it's way better to find one of these libraries and use it instead of using the canvas directly. So in the notes of this slide there is a link to Wikipedia where you can find a list of well-known 3D libraries, actually not only for JavaScript, but there is a JavaScript compartment as well. I've picked one of these libraries to demonstrate. I found this one of the most simplest, so I just want to point out a few things about this library. It's called 3JS. And one of the things I like about this library, it primarily uses WebGL, but it's a complex library which can fall back to software rendering. So it can render the 3D scene manually and display it using 2D context of the canvas as well. It's object-based, so it's much more simple because all the entities like elements of the scene, camera, lightings, everything is an object, and if you need to manipulate with these objects you just simply call predefined methods of these objects. So it's very simple. Instead of providing things like rotation matrices for the OpenGL, you just so it hides all the complexities of this 3D math, and you just call a very simple method that computes all the math for you. And also it has some cool additional features so you can quickly start rendering something. So it has some materials and it can export some 3D data format. So if you have a scene, you can just import it, import the materials and textures, and immediately display the scene. So it's very simple to use, at least for simpler scenarios. Actually, I would like to make a remark here that the most modern frameworks for creating computer games like Unity engine, for instance, today can also render their code into assembly.js. So actually today some of the big players also can use the WebGL inside the browser directly, so you can develop basically your application in C++ in Unity, and then you can render it, you can recompile it into JavaScript so it can run in the browser. I'm sorry, I'm not that versed in game development, so my example will be very simple. This is a very simple utilization of 3JS library. As you can see, I can easily create a box, slap some images as a textures on the side of the box and make it rotate. And this took me only a few lines of code using this library. So that concluded the computer graphics and video, and now we move towards audio. The simplest way how to deal with audio is to use audio element, which is very simple to video element. This element allows you to play a music file or any audio file actually, and similar to the video element you can provide controls so the user can manipulate the audio directly, or you can handle the audio element from JavaScript. If you need something more complex, there is this Web Audio API. It allows you not only to play back media from files, but also from manually constructed binary buffers, and also it provides oscillators for creating artificial sounds. Furthermore, you can add some filters and effects to the playback, so you can, for instance, gain or adjust the volume of the playback. And also this API is related to the WebRTC. I haven't included WebRTC in this lecture. I will cover it in the next lecture. For now, just it suffices to say that this is the stuff related to streaming multimedia throughout the internet. So it's things related, for instance, to the video phones over the web browser. The audio API works as follows. First, you need to create audio context. That's very simple. You just instantiate this constructing class. So you basically create another object, and this context object is then used to operate the audio. To create some playback, to set up this thing in whole, you need to create a pipeline of audio nodes. This pipeline typically should have some source, meaning the source of the sound where the data are taken from, and some destination. Typically the destination is some general thing of the system, so you just play the sounds on the speakers of the system. In the middle you can place some effects, for instance some gaining effects or some monitoring nodes that just monitor the data. As you can see here, there are various source nodes. The simplest one is the oscillator node, which will create an artificial repetitive sound. You can use the audio buffers to manually fill the data that should be played in the system. You can also attach the audio element via this proxy. Actually, you might ask why should we attach audio elements to the web audio API, since the audio element itself can play the sound. Sometimes it might be useful because the audio element will take care of the boring stuff like loading the actual data file via HTTP, and then you can attach it to a more complex pipeline. So if you need some intermediate nodes, some effect nodes in the middle, then you can use audio as the source, which will easily load the file, and then use a complex pipeline to play this sound in the speakers. As a destination, there is only one important destination node, which actually resembles the default destination, i.e. the speakers. Normally you would use this node. I have skipped the WebRTC nodes, so there is the input node, source node, and the destination source for WebRTC, so you can attach the input or the output to some RTC channels, so you can receive audio from the internet or send the audio directly to the internet channel. Between the source and the destination, there may be arbitrary number of intermediate nodes. These nodes can take care of some effects or filtering things, like creating a delay in the sound, changing the amplitude of the sound, things like these. We can also attach analysis node. That's one of the monitoring nodes, which can be used to analyze the data in the stream or possibly visualize them. And also there are some more complex nodes which can affect how the sound will appear positioned in space. That might be important if you want to somehow combine playing sounds and some 3D graphics. I will give you a short demonstration. This demo application creates a very simple audio pipeline. It uses oscillator as the only source. Then there is one analysis monitoring node in the middle, and it syncs all the audio streams into the default audio destination, so it will play the sound on the speakers. I can show you how it works. So I can select the frequency and type of the oscillator, and then if I play the sound, it just simply repeats until I stop it. I can adjust for different frequencies, so you know that it worked. And that's pretty much it. I can also use different types of shapes of the repetitive sound. Some of these are a bit annoying, so I don't want to overstate my welcome. So that's it. The demonstration with the oscillator was rather simple, so I would like to give you a more complex demo which uses data buffers to provide the source of the audio. Again, this one starts with simple initialization. Actually, not everything is here. I will provide mainly the function that puts the data from some arbitrary array buffer into the playback queue. I realize I haven't specified array buffers, and I didn't show you how to work with binary data in JavaScript. That we will cover in the next lecture. However, for now it's not that important. What's important here is how the pipeline is filled. So first of all, we need to create the buffer itself. So we need to specify the specific data buffer only for audio, which has some specific parameters like number of channels or sampling rate. Then we need to copy the data from the array buffer into this new audio buffer. I have intentionally removed this part of code because first of all, you don't know how to work with array buffers or typed data buffers in JavaScript, and second of all, it's highly dependent on how you have your data organized in the buffer. So it's just a technical piece of work. But once you have the buffer created, once you have your data inside the audio buffer, the important thing is how you enqueue them. First of all, you need to get the current time when the buffer will be actually played. So if you need to continuously play multiple buffers, you need to remember the last time the buffer ended and the following buffer must start at the exact time the previous buffer has ended. Otherwise, there will be gaps in the playback which will be heardable by the user. So if there is no buffer been played yet, so the next time is 0, we haven't played anything yet, it's a good idea to start with the current time. This is a very precise timer of the audio API, and it's usually a good idea to add a very small constant to prevent data jittering. So to prevent any gaps in the playback, it's a good idea to slightly delay the playback. This is delaying the playback by 50 milliseconds. And once the audio buffer is ready, we need to wrap it inside the buffer source. So this is how we create a source node specifically for our buffer. We fill it with the buffer itself, and then we connect it to the proper destination context. Of course, if we have a more complex pipeline, we can connect it at the front of this pipeline, and then we start the buffer using the computed time. So this is the most important part. We need to correctly compute the time and set the starting time of this source buffer. And if we want to ensure the continuous playback, we need to add the duration of the buffer. Again, this is a very precise timestamp to the next time, so we know where the next buffer should be started. This lecture should have given you a brief overview of most of the APIs related to user interfaces and multimedia processing inside the browser. I did not have time to cover them all. Most importantly, I haven't covered the APIs for dealing with web cameras and WebRTC. However, I will briefly get to them in the following lecture. So, thank you for your attention, and as always, if you have any questions, you can reach me via email, or you can post comments beneath this video on YouTube.